So in order to calculate the range, what I'm going to do is a few things, and follow me along. First of all, in order to calculate what the range is, I need to figure out what this shape actually is. It looks like a parabola to me, but we need more than, oh, it looks like that for me. We need more equations, right? So in order to do that, let's do it. I'm going to put a line here so I don't erase any of the things at the top. So first of all, I'm going to find the range. In order to find the range, I have to find the path of the parabola. Okay? Okay. How do I find that? Well, I can use, I'm going to call this equation 1. I'm going to call this equation 2. Okay? I'm going to call this equation 3. Okay? And go from there. So what if I take my equation 2? Okay? I can rewrite equation 2 as, oops, I called it equation 2, as delta y equals v0yt minus a half gt squared. And I have from equation 1, t is x over v naught x. See from here? T is x over v naught x. If I have that, I can plug those back into here, which makes it v0y x over x0x t minus a half g, and then, oops, x over v naught x squared. Okay? Then I can use my equation A and equation B over here and plug those into this expression and that expression and that expression. Okay? Which gives me v0y is this. So v0y will be v0 sine of theta times x over v0x, which is going to be v0 cosine theta, minus a half g x over v naught cosine theta squared. Okay? V0s get canceled, and I get sine theta x minus a half g over v naught squared over cosine theta times x squared. So I can call this whole thing as tangent theta, or b, x minus this whole thing as c x squared. So I just called this whole thing as c and this whole thing as b. Does anybody recognize what this looks like? Yep, this is an equation of a parabola. So I know for a fact that this is my projectile motion and it follows the path of a parabola. Okay, good. Having said that, now I can find what the range is. So in order to find what the range is, I'm going to use that expression right here, the one that I had. And I'm going to rearrange things in here slightly. So in order for this to work, I'm going to call this equation, W. So for my equation W, I'm going to come over here. For my maximum range, my delta y has to go to 0. So in order for my projectile to go the furthest out, I want this to be minimum. So once I plug that in here, it'll be 0 equals tangent theta x minus a half g over v naught squared cosine theta x squared. Actually, I'm not even going to worry about tangents right now. I'm just going to leave it as sine theta over cosine theta. Rearranging this expression, I can get sine theta over cosine theta x equals 1/2 g over v naught squared cosine theta x squared. That means 1 cosine goes away, sorry, this is squared. 1 cosine goes away, and 1 of the x's go away. So now instead of this x, I am going to rename this as r because I've just put in for maximum range. This x will now become r. So I will have a sine theta equals to 1/2 g over v naught squared cosine theta r. Rearranging that one, I will get 2 sine theta cosine theta v naught squared over g equals r. And that is my expression for range. If anybody remembers what there is a trig identity, which is 2 sine theta cosine theta can also be written as sine 2 theta, which is going to be great. It makes our life a little bit more easier. So r can also be written as v naught squared sine of 2 theta divided by g. So in some books you will see it written like this, and in some places you will see it written like that. These are exactly the same thing. Okay, they're not different. So take a second, appreciate the fact that we now have another expression for range, which I am going to put over here, because that's important. So my range expression is now going to become v naught squared sine of 2 theta over g. Yay! I know my maximum range expression. Now my next problem is to calculate what the height is going to be. Okay, so in order to do that, I need some information. So for my maximum height calculation, I know that at maximum height, Vf of y equals 0, and V0x remains exactly the same thing. V0x remains exactly the same thing. Okay, now how does this help me? So I have these expressions that can help me. So can you think of a way that this might solve for maximum height? So if I was to take equation 3, which is this one, Vy equals V0y minus gt. That means at my maximum height, this goes to 0. This implies V0y equals gt. Okay, now how does that help me? That helps me if I think that this is the time to maximum height. So this is time to maximum height equals V0 sine theta divided by g. And I put in the value for here in there. Now, I can use equation 2. So instead of delta y, I can put in h as my maximum height, which is going to be v naught sine theta. So I'm using that expression right here. And t at maximum height, which will be v naught sine theta over g minus 1/2 g. T at maximum height, v0 sine theta over g squared, right? I can rewrite this as v0 squared sine squared theta divided by g. So consolidating that, minus 1/2 g v naught squared sine squared theta divided by g squared. G's get canceled, and I can take stuff common out. So that means v naught squared sine squared theta divided by g can be taken out, common, and I have 1 minus 1/2 left over. And that gives me 1/2 g v naught squared sine squared theta as the value of my max h, which I can now add to my hierarchy of equations that I know. So I have a range equation, I have a height equation, I have my initial equations of motion. All of these are going to help me solve problems when I get to those. So now that you have gone through this entire derivations for H and R, you should be able to put all of those information that you have into a table very similar to this that you draw yourself. Trust me, it is going to save you a lot of hassle when you start doing the problems. Here's another suggestion that I'm going to make for you to be able to do these problems. So for example, forces and accelerations and velocities. When you look at a problem, think of these questions. So forces, are they present in the horizontal motion versus the vertical motion? Are the accelerations present in the horizontal versus the vertical position? Are the velocities changing or they're not changing? So these are questions that you should ask yourself before every problem. And just to give you a little more idea, the important formulas that you may want to remember as you solve these problems are given on this page. So take a second and go through these, the velocities, the directions, the y, the x directions, and the range and the height calculations are also given here.